Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. The Honorable Professor Dr. David M.Sc. Ph.D. as the head of PUI-PT Combinatorics and Graph. The Honorable Dr. Sunder, Ph.D. as the invited speaker today, and all participants in this colloquium. Welcome to the Colloquium, Optic Segmentation and Glaucoma Classification on Retinal Image using Deep Learning Models. First of all, let's say thanks to Allah who has given us guidance, happiness, healthy, and mercy, so we can attend and participate in this event without any obstacle. Praise and salutation upon our Prophet Muhammad Sallallahu Alaihi Wasallam. Ladies and gentlemen, in this special morning, we would like to inform about our agenda today. Please allow me to read several sentences of our agenda. First, opening. Second, singing the national anthem of Indonesia Raya. Third, singing hymn of University of Sunder. Fourth, opening remark from the head of PUI-PT Combinatorics and Graph, and official opening of the colloquium. Fifth, reading of prayers. Sixth, presentation from our invited speaker. And the last is closing. Ladies and gentlemen, to take advantage of the time, let's start agenda by setting basmalah together. Entering the next agenda, that is singing national anthem of Indonesia Raya, and the hymn of University of Sunder. Ladies and gentlemen, please stand. Thank you. Ladies and gentlemen, please take your seat. And the next agenda is opening speech and reading the prayers will be given by Head of PUI-PT Combinatorics and Graph, Professor Dr. David M.Sc. Ph.D. Please welcome.
Thank you all for inviting me for this session. First, I would like to thank David for inviting me for this colloquium series.
Yeah, Sunder. Good morning.
Thank you, sir. Good morning, sir. Good morning.
Yeah. Okay. I'm still on the way to go to campus. Maybe 5 minutes later, I will be there.
Okay.
Alhamdulillah. I will start with my speech first before you present your presentation.
Okay.
Assalamualaikum warahmatullahi wabarakatuh. Good morning for everyone. Honorable Rector, Vice Rector, and Head of the SIGAN, Combinatoric Graph Theory and Network Topology, and Honorable today our joint researcher, our collaborator, Dr. Sunder from India. He is actually a friend of Venkata Chalam. He just back from Jember City from our university. So please welcome to our university, Dr. Sunder. Today we will have just a discussion prior to have an international conference. I'm just looking forward to seeing you in Jember University and working on the machine learning. Yeah, actually we just start with the machine learning right now. Actually, our research group actually are focusing on the combinatoric graph theory and network topology. But in the recent research of interest of machine learning, there are specific topic which is quite related with the combinatoric and graph theory, namely graph neural network. That's why I would like to hear whatever you present today, and after get back by university, I will have a good discussion with you during 1 hour, for example. Then maybe within 2 days you're waiting for leaving for Indonesia, maybe you can browse some notion about the graph neural network. I believe that's all from me today, and I would like to welcome Mr. Sunder to present his topic. I am formally open this session for all of you. Thank you very much.
Thank you, sir. Thank you.
Yes. Okay.
Shall I proceed?
Yes, I believe. Yes, you can start that. Yeah. Please. Yeah. Okay. Yeah.
And dear student, can you enable the screen sharing?
Okay. Anis, coba di share screen-nya dihidupkan, Sundar. Anis, ya. Ya. Just a minute.
Yeah, it's okay.
Doctor. Yeah.
Yes.
Okay, Professor David, thank you for your opening speech. And the next agenda is our main agenda, that is presentation by our honorable speaker, Dr. Sunder, Ph.D. And in this session will be moderated by Mr. Ilham Bayhaqi. Ladies and gentlemen, please welcome our moderator, Mr. Rifki. To Mr. Rifki, the floor is yours.
Okay. My dear students, I hope you are hearing my words. Is it right?
Yes,
Yeah.
yes. Okay,
Yes.
okay. Please continue.
Yes, sir.
Yes. Okay, good. So happy to see you all this today morning. As Professor already said, you people are working with graph theory and combinatories. Recently, you have started the research on machine learning and neural network. So the basic idea, basic elements, basic attributes behind the machine learning and artificial
Excuse me,
neural.
sir.
Yeah. Yeah, I can hear you.
Okay.
Can you see my PPT?
Yeah, could you please slide show your PPT? Make it slide show.
Yeah. It's okay.
Yeah, it's okay. It's okay.
Okay, fine. So behind the topic of machine learning and artificial neural network, I am going to give a brief introduction about this. Okay. So during the presentation, if you want to ask anything, you can. At the same time, you may have a notebook and calculator for solving the basic problems. Okay. So soft computing. This is the umbrella of machine learning, artificial neural network, data science. Okay. So obviously, there will be a word hard computing. Okay. So hard computing, soft computing. What do you mean by computing first? That we want to know basically. My dear students, as a mathematician, okay, you may have one model or formula or algorithm or control function. Okay. So if I have given the input, your function will produce the output. That function or algorithm or model are, there is no unambiguous. It's perfect model. Okay. So I'm giving the input, that model will produce the output. Okay. So I'll tell you, you can see my presentation. Okay. Computation. Now there is a function f of x. Okay. If you are given the x, it will produce the output, that is y. Okay. That is what the computation. Okay. Now I'll come to the point. Hard computing, soft computing. Okay. Hard computing, that means already I have mentioned standard function, control function, formula, algorithm. Okay. Will be there and there is no unambiguous about it. So when you given the input, it will produce the output. That is what hard computing. Okay. So the results are precise one. The results are precise one. How many times you are given the same input, that hard computing will produce the same output. Okay. So that is what the word of keyword of hard computing. Okay. Next, the new keyword soft computing. This is the umbrella of all the keywords: artificial neural network, machine learning, then data science. Okay. So what is soft computing? Okay, so here there is no formal method. Soft computing means, okay, we don't have any formal method, and it doesn't going to give the precise result. It doesn't going to give the precise result. Okay, but at the same time, the result will be close to the expectation, close to the accuracy. Okay, and this model can adjust into the dynamic environment. It can be adaptive. This algorithm can adaptive at any environment. Okay, so that is what our focus. So when you are given the input, okay, the soft computing technique will produce the output that is precise, not the precise, okay, close to the accuracy. Understood? Close to the accuracy result. And this soft computing method is what we can say, no formal method, not like a formal function or algorithm or control function. Okay, so we are developing one algorithm, okay, based on the problem, okay, and it will give the result, okay, which is close to the accuracy result. Okay, so that is what basic soft computing idea. Okay, now we can talk about artificial neural network and machine learning. This is what today I am going to give a basic idea about it. Okay, so artificial neural network, you may hear the word artificial neural network. Can anybody, could you tell me about the word? Any idea do you have? Do you have any idea about it, my dear student? Okay, fine. I'll continue. Say, artificial neural network is a information processing system. Okay, there is one model already I have mentioned, model, function, algorithm. Okay, so artificial neural network is a information processing system which resembles the characteristic of human brain system. How our human brain is working, how the structure of our human brain system. Okay, the replica of that only artificial neural network. Okay, so the key element of artificial neural network, the key element of artificial neural network is that novel structure of information processing system. Novel structure of information processing system, and it is composed of a large number of highly interconnected neurons, which is uniformly performing for the given problem. I hope you have got a bit idea about the artificial neural, how our human brain is working. In our human brain, fully filled with neurons, and it can be highly interconnected. Okay, the same way, the replica of human biological nerve system, we are giving the structure for artificial neural network, which uniformly working for that particular problem. So the neurons in the network, it is highly interconnected. Okay, so that is what the basic definition of artificial neural network. Okay, my dear student, I will give a simple neural network structure. I'll tell you, very simple one. Just note it down. I'll write. Look at that. input layer, output layer. Okay, so any artificial neural network, there will be a input layer and output layer. You may hear the word deep learning. You may have seen my title, deep learning models. So between input and output layer, there will be a n number of layers. That means that is a deep learning. So before that, I'll tell you what is the structure of basic artificial neural network. Okay, let us consider the neurons are, you may correlate it into the graph. Currently you are working in the combinatory and graph theory, so you can correlate with this your research area. Okay, so in the input layer, there will be a 3 number of neurons. In the output layer, there will be a 1 number of neuron node element. Okay, according to your research, you can climb vertices. Okay, so I can give the label for each neuron. This is x1, this is x2, this is x3. Okay, the output neuron, I'll give the label y. Okay, so when you are working with the data set, what you have received from your research, okay, you have a number of features. You have a n number of features in your data sets. So that we are going to given in the input layer to classify the output. Okay, so this is now the neurons are going to connected with other layer. So here the x1, x2, x3, these neurons are going to connected to the output layer. Look at that. I am going to connect the neuron. Okay. Now the neurons are connected. Every layer neurons connected with other layer neuron. Okay. Now I am going to give the input. Okay. This is the features of the data set we can given in the input neurons. Okay. The inputs are just, you assume that 0.3, 0.5, then 0.6. Okay. Now between these two layers, there will be a connection link. Okay, associated with one weight. This is what very important, W1, or I can write the weight 0.2, 0.1 minus 0.3. Okay, so my dear students, every neuron connected with other layer neurons, and it is highly interconnected. So we may have the data set. Okay, the data set features, that features we are going to given in the input layer. Okay, and the associated weight between the two neurons. Okay, so in the output layer, there will be one neuron. That one neuron, how the net input will be for the output layer. Okay, so the before getting the output, okay, we may have the calculated net input. Okay, calculated net input. How the inputs are going to sum and given as a input to the output layer. Okay, so yin equal to, the formula is xi comma wi, summation of I equal to 1 to Yeah. So my dear students, you can calculate the YIN. That means YIN means calculating the net input. Okay, calculating the net input. So Xi, X1. So here let us consider this is X1 into W1. This is W1, W2, W3. This is input is X1, X2, X3. Okay, so X1 plus W1, X2 plus W2 plus X3 plus W3. Okay, so I can write like 0.3 into 0.2 plus 0.5 into 0.1 plus 0.6 into minus 0.3. Okay, so this is what the input going to the output neuron. Okay, so can you calculate the value of this YAN? What's the value? Okay, so after do the calculation, you will get the value minus 0.7. Okay, so we are given the input into the input layer. Okay, then this input layer is highly connected with output layer neuron. Okay, so what is the input for output neuron? Output layer neuron. Okay, so this is the way we have to calculate the net input for the neuron. Okay, so you just imagine that if suppose output layer there will be a 5 number of neuron. Okay, so every neuron in the same way we have to calculate, that is what the input for the every neuron. Okay, so I hope you have understood what is the calculated net input for the output neuron. Okay, now suppose you, for simple example, I'll tell you, in the output neuron or output layer, there will be a activation function. Okay, activation function. The purpose of activate, you may hear the word activation function, which is used to make the output is more effective. To make the output is more effective, we are using the activation function in the neuron. Okay, so let us consider simple activation function f of x equal to x. F of x equal to x. Okay, so apply this activation function into the output layer neuron. Okay, so the given input is for the input for the output layer neuron is 0.7. Okay, so after that we are applying the activation function, so it will give the output y, that y is minus 0.7. Okay, so this is the simple neural network architecture for understanding what is neural network and what is the calculation behind the artificial neural network. Okay, so I'll add one more slide. Okay. Wait, I'll add some slide for solving some. Okay. Now, one more keyword you should know, that bias. Okay. Bias, which has to include every neuron between the output and input layer. This is input layer, output layer. Okay. So neuron, let us consider two neurons in the input layer. Let us consider output in only one neuron. Okay. See, the neurons are highly interconnected. This is X1, this is X2, this is Y. Okay. Input we are given in the input layer. Here we are going to get the output. Okay. So inputs X1, X2, this is W1 and W2. Okay. So inputs are X1, X2, W1, W2 means synaptic weight between the neuron connection. Okay. Now I am going to add the bias. Okay. So bias to make the impact on the calculated net input. So this bias input always be 1. Okay. And the weight is B. Okay. So how we are going to calculate the net input? How we are going to calculate the net input? Net input means here you are getting, this is net input, YIN equal to. Okay. So bias input dot the weight, bias or weight B plus summation of summation of I equal to 1 to N Xi and Wi. So this is the way you are calculating the net input for the output layer neuron. Okay. After that, you are going to apply the activation function. Okay. For your better simple understanding, I have given the activation function is identity activation function. Okay. F of x equal to x. You know how to calculate the net input and apply the activation function. Okay. So very simple. This is the basic architecture for the artificial neural network. See, here I have added B. B is a bias. Okay. Except input layer, every layer we can add the bias for each neuron. Why? What is the reason we are adding the bias? To create the impact on the calculated net input. What is YAN? Net input. So to make the impact and the calculated net input. That is why we are adding the bias into the network. Okay. So this is the simple architecture I have given. Okay. Now the architecture of ANN architecture has 3 components. Okay. ANN architecture have 3 components. One is connections. Connections. 2, learning. Okay. Learning. 3, activation function. So before approaching any problem, you should know the architecture of artificial neural network. Okay. So my dear students, for connections for the architecture maybe have many forms. Okay. I'll tell you one by one. Connection can have a different formats like single layer feed forward network. I'll tell you single layer feed forward network, then multi-layer feed forward network, then single layer recurrent network, okay, multi-layer recurrent network. Okay, so connections can be classified into 4 number of categories: single layer feed forward network, multi-layer feed forward network, single layer recurrent network, multi-layer recurrent network. I'll tell you one by one diagrammatically, you can easily understand. Okay, look at that. Already I have mentioned there will be an input layer and output layer in the architecture. Okay, so here single layer feed forward. Okay, so there will be a neurons x1, x2. When you are approaching the big problem, okay, you may have n number of neurons in the architecture, x1, x2, and xn. Okay, output layer, there will be a neurons like y1, y2, etc., ym. Okay, m number of neurons. Okay, I'm talking about single layer feed forward network. Okay, so here there will be a inputs. Okay, the input layer neurons highly interconnected with all the neurons in the output layer. So you know the connections. Okay, my dear students, every neuron, it has to connect to the other neuron in the other layer. Okay, I hope you are, it is very simple one. Okay, every neuron connected to the output layer neuron. Okay, okay, feed forward. Okay, so the output is going to get from the output layer. Okay, but every neuron in the output layer receiving the input from the previous layer. Okay, that is why we are calling this is a single layer feed forward network. Okay, so between the two neuron connection, there will be a weight W1, W1, 2, W1, 3. Okay, so this one W21, W22, W23. Okay, so here WN1, WN2, etc. Sorry, 3 L. There is no 3 M, etc. Okay. W N. Okay, so this is a single layer feed forward network. My dear students, if you are approaching any problem, you should know what is the architecture we are going to use for the particular problem. Okay, one by one, you can easily understood. This is a single layer feed forward network. Okay, now I'll move to the multi-layer feed forward network. This is the beauty of the I'll add a few more slides for okay, this is single layer feed forward, multi-layer. So this could be a deep basis of deep learning model. Okay, recent times people are using deep learning techniques to detect the output using the deep learning models like I'll tell you input layer, here output layer, between there is a hidden layer. Okay, hidden layers. Okay, this is the basis of deep learning model, etc. You should know the architecture. Okay. Okay. Inputs are x1, x2, etc. xn. The output layer y1, y2, etc. ym. Number of neurons in the layer. Okay. Now, see, there will be a hidden layer. Okay, this is the beauty. Okay, so between input and output layer, here I am adding only 2 layers. Okay, the between input and output layer, if you are adding n number of layer, okay, in which you will get the high accuracy. Okay, that is why we are looking for the deep learning model for any kind of diagnosis of medical disease. Okay, so Z1, I'll give the label for the neuron, Z2, ZK, then R1, R2, some RQ, some number of neurons. Okay, now everything is highly interconnected. Okay, every layer neuron will be highly interconnected. If you know the concept, what I'm going to draw is very easily you can understand. Okay, see every neuron, okay, highly interconnected with other layer neuron. Okay, every neuron in the layer which is highly interconnected with other layer neuron. If we know the concept, it is very simple architecture only. You just imagine that 16 between input and output layer, there will be a hidden layer 16. Okay, that is what I have approached for my problem, VGC 16. Okay, this is the basic idea of deep learning model. So, my dear students, between here you have to understand one thing. Between any two neuron, there will be a connection. Okay, you maybe in your graph theory, okay, you may have a graph. Okay, so you call it as edge. So that edge you may have some value. Okay, that edge, that synaptic weights we are adding into the edge between the two vertices. Okay, in such a way you could correlate into your field. Okay, this is the multi-layer feed-forward network. Forward network. Only processing is forward mode. Okay, now I'll talk about that single node, that single layer recurrent network. Yeah.
Dr. Sunder.
Hello.
Would I ask something?
Sir, I
Would
couldn't
I
hear
ask
you.
something?
Yeah.
Yeah. If you show me only 3 layers, including input, hidden layer, and output layer,
Okay.
is that a simple artificial neural network?
Okay.
And if you have 2 hidden layer,
Okay.
is
So
it
here
consider
here,
to be deep machine learning?
yes, more than
Okay.
2, more than 3, more than 4, between input and output layer. Okay, if you are increasing the hidden layer, in which you will get more accuracy for your problem. Is it right, Professor?
Again, I will ask.
Hello? Professor, your voice is not audible. Hello? Hello? Professor, shall I continue? Hello?
Effectively, or to see the application, whether it is a linear
Hello?
application
There is
or
a echo.
exponential, can we choose in what analytical way instead of can you hear me?
No, Professor, I couldn't hear your voice clearly.
So if you run a program, you need an active function. Am I right?
Professor, your voice is not clear.
Yeah, sorry, I just if you run artificial neural network to have an output, you need an active function. Am I right?
Yes, activation function. Yes,
Yeah.
exactly. Yes,
How-
Professor.
Yeah. How do you choose an active function effectively instead of choosing by trial and error in the computer code? Can you choose by mathematical or analytical approach?
Yes, Professor. Good question. See, in the output layer, okay, we are applying the activation function. The first simple problem itself, I have explained how we are applying the activation function into the output layer neuron. Okay, very simple activation function I have taken. F of x equal to x. What is the input calculated net input? The same only will be the output. That is the activation function I have applied. Now, what Professor is suggested, analytically, or how we are going to select the activation function to apply into the output layer neuron. Good. Suppose we need binary classification. Okay, why we need a binary classification? That is what the first question. Before constructing the architecture, we should aware about it, the data set. Okay, data set we should aware about it. In the data set, I'll tell you the very directly. I'll come to the data set x1, x2, y. The inputs are 1, 1. The output is 1, 1, 0, 0, 0, 1, 0, 0, 0, 1. Sorry, 0. Okay, let us consider this data set. Okay, so here you can see the number of features in the data set, x1 and x2. the labels are Y. Okay. Here the output are label only 2, right? Either 1 or 0. We have a samples 4. Okay. Now we are constructing the artificial neural network. Okay. Like I'll tell you very simple. Okay. So here, after calculating the net input, we are going to apply the activation function. Okay. So here you see that what is the activation function I'm going to use here? Binary activation function. Binary activation function. Okay. Binary activation function. So after calculating everything that calculated net input, you have to apply the binary activation function. If f of x equal to 1, if the calculated net input which is greater than the threshold, 0, if less than the threshold. So here you may consider the binary activation function, which is going to apply into the output neuron in the output layer. Okay, which will fire the neuron to make the output is either positive 1 or 0. Okay, so Professor.
Doctor.
Okay, so but based on the labels in the data set, first we have to investigate here the 2 classes. Okay, that is the reason
Doctor, can I interrupt?
Hello.
Yes, doctor. Doctor.
Yeah.
Could I ask something again?
Could you repeat?
Could I ask something again?
Yeah, please proceed.
Yeah. Okay. I understand if the target is a binary, just like a logic in mathematics,
yes.
But if you have like input are on the intervals data, say range 0 until 100.
0 to 100. Okay.
And the target is also interval data.
Yeah. Tell me the range.
But we could have a difference interval range, for example, 0 until 1,000.
Okay.
Yeah.
Good.
Could you hear me?
Yes, Professor.
Yes.
Good question. I'll tell you.
Choose without any normalization, of course, I didn't do a normalization on that data, even in either in the input data or target data. If we choose the activation function is tangent hyperbolic function.
Yes, tangent.
Or we choose bipolar sigmoid.
Okay.
In mathematics, it is considered to be a rational number.
Okay.
Yeah. So of course the output, if we do not do a normalization, it will be far from output and the target, because we couldn't get the output as a interval that is this in the target, because we use tans and or bipolar sigmoid as a activation function. What do you think, brother?
Yes. Nice question, Professor. Before that, we should understand the problem. Okay, that is already Professor mentioned. I'll tell you X1, X2, X3 are the features. Okay. Let us consider. Okay. The labels, before coming to your question, I'll tell you a few explanation. Okay, see, we have seen the data set. Okay, the data set, if you have the training pair, if you know the input as well as output, if you know, we can go for supervised learning techniques. Supervised learning techniques. Why we are choosing the supervised learning technique? Because we know the input as well as output. We know the training pair. Okay. At the same time, you can consider the labels. That means targets. That means output. Here, there will be only two type of classes or target or output. Okay. Either 1 or 0. Such kind of problem we are going to approach.
Doctor.
Yeah.
Would you change the target?
Yeah. That I'm going to.
Interval data.
That I'm going to, Professor.
Binary data.
For example,
100,
yeah.
75. Yeah, 75. Okay. And then, yeah, okay. 8, yeah. Okay. So, if you put the activation function.
Yes. I'll tell you.
Yeah,
that is right. See, first, if there is a label 2 class, we are going for binary classification. Second, the labels are more than 2. Here, more than 2, but it is not finite. If there is a finite, okay, we can go for multi-class classification. So here it is what the range between the range of value is not finite. If it is finite, we can go for multi-class. So, sir, Professor, are you talking about finite number of label or infinite number of label?
Now, what I'm asking you, what the best activation function will you use if you have this kind of target?
Yes, we can go for by sigmoidal activation function, binary sigmoidal activation function, bipolar sigmoidal activation function for binary classification. For here, we can go for tangent. Okay, so there is a range between 0 to 1. We can convert into the range 0 to 1 after applying the tangent activation function into the calculated net input. So this is a regression problem. Okay, so we have to apply the regression method for this data set, and the activation function is tangent. Understood, Professor? Professor, got it? Hello?
Say it again, brother. Normally, when we use programming, either in MATLAB or in Python,
we can use
choose in random. First, for example, we choose sigmoid, bipolar. If it is not good, the M.Sc square error is not good, and then again we choose other. We choose Retinal, we choose tan, Again, we just see the approximation of the output and target. If it is not good, then again we choose again. Is there any way, in mathematical way, analytical way, that we can predict in advance for the activation function? What do you think, brother?
See, every epoch, we are training the samples and calculating the mean square error. Okay, so the number of epochs increasing, the target is also almost reached to the accuracy. At the same time, the mean square error, it has to reduce by each epoch. Okay, so the minimum error can be, okay, it doesn't matter, but the accuracy which is close to the expected output, that is what very important. At the same time, we can do the trial and error of number of epochs, okay, and calculate the mean square error. And there will be a evaluation methods for checking the training accuracy and test accuracy. Okay, okay, Professor. Hello, Professor, your voice is not audible.
Maybe we will talk later after you come down to Jember.
Yeah.
This.
Okay.
Yeah.
Okay. Okay.
Yeah.
Shall I select?
Okay.
Yeah.
Okay. Okay, doctor. Probably to make sure that our discussion, we can get a good discussion after you get our university next week.
Yes.
Yeah.
Yes.
Okay.
Yes. Okay.
The second question, brother. The second question. If you say X1, X2, X3, X1,
Yes.
X2, X3,
Okay.
that's the input data. Am I right?
Yes. Input features.
Input features. The first features, 1, 2, 3. The second features, 4, 5, 6. And the last features, 8, 7, 9. Am I right?
Yes. This is sample.
Yes.
For example, I have considered.
Yeah. All those features I consider are independent each other.
Yes.
The first features is not affected by the second features.
Yes.
The second features is not affected by the third features.
Yes.
And so on.
Yes.
Then I say these features are independent features.
Yes.
What happens if those features are dependent each other? Do you think artificial neural network is applicable for this input data?
We can go for graph neural network. Actually, every node, it will share the information to the nearby
Could
node.
Could I share information to you?
Yes. Every node.
Okay. Do you have still time?
Yeah.
Okay. Yeah.
No, Professor, I want to, I think 5 more minutes I can spend, if you permit.
Do you have still time?
No, only 5 minutes. I want to go to college. Sorry for that.
Okay, okay,
Actually,
brothers.
the beautiful topic you have selected, that graph neural network. It's a emerging one. At the same time, after.
Would I have 5 minutes?
Yeah, yes.
Okay, okay, okay. Yeah.
Yeah. But recently I have gone through that graph neural network. Okay, after your information only, I have gone through how the graph neural network is working. What's the hidden?
Yes. In
Yes,
5 minutes, yeah?
Yeah,
Okay,
yeah.
because you will go to office, yeah.
Yes.
That's a graph neural networks.
Okay.
We have a lot of input data which is connected to each other. It is not independent.
Professor,
For
please
example,
present.
if an computer
Hello?
network, this is part. And also this one, social network. Yeah. And also this one.
Yes.
Yeah, okay, yeah.
Yes.
Okay. Now, what is graph neural networks? Actually, I'm sure that you already know about the graph, but
Adjacent matrix.
yeah, we are all the time, much of time in graph neural network, we are focusing in matrix adjacency. Yeah. Because what? The each features is not independent each other, but each feature affecting each other. So that's why we apply a message passing algorithm. Yeah. So this one, the input of features in the artificial neural networks. So what I'm thinking is, sorry, I just skipped this one. Instead of having this Euclidean source, when you are thinking about, you are using convolutional neural network, for example, you are considering the glaucoma from eyes, human beings data, for example, I believe your data in Euclidean source, either it is in image, something like this, yeah, or in this one. If it is signal or speech or text as a source. But what happens if we have network something like this? And we are concerned about this kind of thing, non-Euclidean source in networks and versus Euclidean source. We are not much working on this kind of artificial neural network, but right now, of course, to start with this kind of notion, we should start with the artificial neural network. But in the future, we will work with this one. Yeah. So the data in each vertex or in each nodes have features, but each not connecting each other. It means there is affection from the neighborhood of the features. Okay. In the graph neural networks, the task could be in the node level prediction, or in the lane level prediction, or the whole graphs. For example, for the node level prediction, you can say in the knowledge graph in the internet, and you have a Facebook or Instagram, there is like a friend recommender. That's not level prediction. Yeah.
Yes, exactly.
Okay. And level prediction as well. You have got this one. We will talk later on after you get to Indonesia. And what is that? For example, here in the first social network, yeah, there is some friendship in the Facebook, for example. Someone have a friend to each other. But of course, everyone has a features. For example, age, weight, smoke, and the history why they have a friends. Of course, I believe because the similarities of that features. But when we analyze this data input, we consider the connection between that feature. So that's why we call graph neural networks. So I believe this one, brothers, for the initial information, probably before you leaving for Indonesia, you have a time to browsing. That's now we are in what level or stage studying about the graph neural networks. But I believe I'm still want to learn deep, especially in the or future time by using Python, yeah, using Google Colab. Yeah. Thank you, brothers. I'm sorry I have bothered your time because you will go to a college. Then, yeah, that's from me. Yeah. Okay. Thank you. Thank you.
Thank you, Professor Defik, for giving me the opportunity to visit your campus. And this new research will helpful for both of us, and we can investigate the data set what you have. Then we can find the what kind of algorithm, like learning models, supervised or unsupervised model we are going to taken place for this research. Actually, all social media are using this graph neural network. See, we two may not be a friend, but if I like your post or video or your article, then the social media will recommend you. Whether you do you know about him? Can you accept him? Okay. So in such a way, the cluster, the group of community is creating. Okay. In the world, any two person in maybe in a different continent, but the interest on the topic, video, or whatever it is, attribute, that attribute you have a common. Okay, the media will suggest you two are in the same community. How this will happen? Okay, so the beauty is the graph neural network. Okay, at the same time, one more example I can give. If you are searching, if you want to find some product in the e-commerce website, okay, then immediately that e-commerce website will suggest a few more product which is relevant to you.
Yeah. Good.
Yes, yes.
Yeah,
Okay.
that's product recommendation.
Yes,
If you
yes,
buy
yes.
something right now, and the platforms will recognize
Yes,
what
yes,
you
yes.
bought already, and they
Yes.
recommend the other products to buy. That's
Yes.
exactly graph neural network.
Yes,
Very good, brother.
yes, yes. At the same time, not only that particular e-commerce website, the other e-commerce website also will come into your social media. How the things are happening? Because
Okay.
all the nodes are highly interconnected and sharing the information. That is what last you have asked the question. Okay.
Yes.
The features are highly correlated. The features are sharing the information. Okay, sharing the information among the. Okay, so that is what the background
That's
of.
enough, brother. Enough.
Yeah. Okay. Okay, Professor, thank you for creating this platform for sharing the information. So we'll see you in your university physically. We can have a fruitful discussion among your research scholars as well as your team, Professor.
Thank you, brother.
Thank
Okay.
you. Thank you so
Thank
much.
you, thank
Thank
you.
Thank you.
Yeah. Yeah, okay.
Definitely.
And see you next week. Yeah.
Yeah, next week. Yes.
Have a good trips. Have safety trip, and then we will meet soon. Yeah.
Yes.
Okay.
Thank
brother.
you. Thank you
Thank you,
all. Thank you for your support. Thank you so much.
Thank you very much. Thank you very much. Nah, itu kan.